The Earth is the only place in the entire solar system where you can stand and watch a total solar eclipse. No, not just because the Earth is a rocky planet and you can stand on it, but also because of the following cosmic play of numbers. The Moon is 400 times closer to the Earth than the Sun, but at the same time, its diameter is 400 times smaller than the Sun. These two factors cancel out each other exactly, and hence we get to see a total solar eclipse from the Earth. For many centuries, eclipses were viewed as bad omens that brought death and destruction. But for scientists, solar eclipses have proven to be good friends. In this video, I'll tell you about 3 solar eclipses that proved to be a turning point in the history of science. Stay with me till the end, and you'll see how an alignment of these 3 celestial bodies can change our understanding of the cosmos. This man needs no introduction. He was one of the smartest people to walk the planet. Though he regarded Isaac Newton as his idol, Einstein was not convinced with Newton's idea of gravity. Einstein spent a decade formulating his theory of general relativity that describes gravity as a curvature in space-time. It gave an unexpected twist to Newton's perception of gravity and was one of the most revolutionary works of the early 20th century. But no matter how magnificent a theory is, it is still just a theory unless experiments verify it. And same was the case with Einstein's theory of general relativity. It needed experimental verification, which, 4 years later, came from a total solar eclipse. Confused? Stay with me. One of the most vital predictions of general relativity is that gravity bends light. Whenever a light beam passes by a massive object such as a star, it gets deflected by the star's gravity. The plan was very straightforward. It was to photograph the total solar eclipse and compare the position of the stars behind the sun to that during the nighttime. If the measured angle of deflection matched the predicted one, Einstein would be correct. The first attempt to photograph the eclipse was made in 1914, but because of World War I, the team of astronomers could not capture the eclipse. Eventually, on 19 May 1919, Arthur Eddington successfully photographed a total solar eclipse, thus verifying Einstein's general relativity. But this isn't the only remarkable breakthrough associated with a total solar eclipse. When the moon covers the entire solar disk during an eclipse, a bright aura is seen around the moon as shown. This aura baffled astronomers for many years. They believed that it was an outcome of sunlight reflecting off the moon's atmosphere. But we know that the moon virtually has no atmosphere compared to the Earth or the sun. So, what does this aura represent? After numerous observations, in 1734, a French-Italian astronomer named Maraldi figured out that the aura was actually a part of the sun's atmosphere. Today, it is known as the corona and is the hottest region of the solar atmosphere. However, until the 1930s, we did not have proper instruments, and the corona could only be seen during a total solar eclipse. The moon passing in front of the sun blocked its glaring light, thereby making it safe to look at it. Astronomers observed the sun's atmosphere with a spectroscope that separated white light into a spectrum of colors, just like a prism. But while making similar observations during a total solar eclipse in 1868, an astronomer saw an unknown yellow line in the spectrum. This line was later found to be produced by a new element, now known as helium. Hence, a solar eclipse led to the discovery of the second element of the periodic table. To end this video, I would like to quote Marie Curie, "Nothing in life is to be feared. It is only to be understood. Now is the time to understand more so that we may fear less." Do share this video with your friends and follow our page for more such videos on science.